Hello, everybody. Thank you for being here. Welcome to Lifecycle Management of Docker Clusters. My name is Andrew Shu. I'm an engineering manager here at Docker, and I'll be your MC for the session. We have with us today Joe Abbey, Director of Engineering at Docker, flying in from Indianapolis. He'll be pairing up with Aaron Ruth, Senior Solutions Engineer at Docker from Seattle. Fun fact about Joe, he's got 6 kids. He knows how to handle it. I asked him, like, how did you end up with 6 kids? He says, consistent release cycle. He knows what to do. Aaron likes to brew beer. He's never brewed a bad batch of beer. Because his beer brewing system is automated with computers. Robots, they're going to take our jobs. This session will demonstrate a new tool for managing the lifecycle of Docker in Kubernetes environment. It's built for Docker Enterprise. It enables enterprises to automate initial platform deployment as well as common day 2 and day n operational tasks. Also highlight how this is used for initial deployment, but also it can be leveraged for backups and restores, scaling up or down clusters, and can be extended for multi-cluster use cases. Please give a warm welcome. Thank you.
Clicker not work now?
We're off to a great start. All right, great. Yeah, I mean, the trick with 6 kids is just to remind them that you treat everything like cattle and not pets. So survey! Welcome to DockerCon. So who knows what Docker Enterprise actually is? Oh, we got some hands up. Good, the SE raised his hand, good. Excellent, just a few, all right, yep. Okay, what about who has deployed a Docker Enterprise cluster? All right, some.
More than I was expecting.
Well, raised hands, good. You want to take this one?
Yeah, so kind of show of hands, how many nodes have you guys seen? Like, who's done 5, 10, 50, 100 plus? Oh, we got one back there, so he knows the pain. And then how many of you guys use automation when doing that?
Oh, good.
Yeah.
Human automation or? I mean, I have 6 kids. So.
All right, who's deployed the Kubernetes the hard way?
Oh, we got a couple.
So you really know the pain. Yes, kind of some of the stuff we've noticed, in dealing with all these clusters and with all kinds of customers is that, clusters are hard. So you got this clicker here.
Yep.
There's a lot of implementation considerations that you have to go through: the architecture, the design, the planning, and then moving on from that, you have to have all the infrastructure and then the actual execution. And so what we found is manually deploying a cluster is extremely time-consuming, and then being able to actually hit the best practices and make sure they're applied is usually not that trivial. And the whole cluster process requires lots of cross-functional expertise. And so getting everybody in the same room and getting that all nailed down and knocked out takes time.
Yeah, so things you have to think about are, what's the instance size? How much disk space am I going to use? What region are we going to deploy to? What's our load balancers going to look like? Who do I need to talk to get the SSL certs? What OS are we going to deploy on? What version of Docker? By the way, what's the version matrix of Docker? And so just to have to get through all that and then finally deploy it, there's a lot of variables, and in a lot of engagements, we've seen this take 2 weeks of time to go from, hey, I want a Docker cluster to, all right, here you go.
2 weeks of time is pretty short.
Is that short? Okay. So we would like to introduce to you today Docker Cluster. It is based on some feedback we had from Docker Certified Infrastructure about 1.5 years ago, where we, in Docker Certified Infrastructure, built a set of Terraform and Ansible scripts, and we had those basically available for people to use. And the feedback was, that's great, but make it easier. because this is really hard and I don't want to learn Terraform and Ansible unless I already know it. So what we did was we took those scripts and templates. We built a CLI plugin around it, which integrates with the Docker desktop client. So you can type Docker cluster. A companion container to go with it, which includes all the tools you would need to do the provisioning, and of course the scripts and templates themselves in that container. And finally, what makes a really big difference is a declarative model, and we'll dive into this a little bit more about what we mean by that. So why do we do this, Aaron?
Yeah, so why we kind of took the declarative approach is now you can source control your cluster YAML files, and then that can all be tied into a GitOps type of approach, so that instead of going in and manually having to manipulate all this stuff, somebody has to push in a request. It has to go through code review. It has to be approved. Once it gets in, go through your full CI/CD flow and actually make all of the modifications to your cluster automatically through that GitOps flow. And then that also allows you to do the automated deployments of your initial cluster, which like I mentioned, hitting all the best practices for that is difficult. And we have, if you go to the success.docker.com page, and you look at our best practices document, it's fairly lengthy, and so ensuring all that information gets put into your cluster isn't trivial, like we said. And then moving that out, now you're getting some day two operations out of this, where used to be with like DCI, it could do a little bit of the day two operations, but it didn't always follow best practices as far as how do you do an upgrade? Do you upgrade the managers one at a time? Do you then upgrade your DTRs one at a time, and then you can move on and say upgrade a percentage of my workers all at one time? And so it gives you a lot of flexibility around your day two operations as well.
So let's talk more about the declarative model that we're calling, until we get a better name, cluster YAML. So like we mentioned, it's a declarative model. There'll be 4 major sections. The first section that we'll talk about is variables, because we'll want to have some way to basically make the overall shape parameterized. So you can give it a name and then a value. Then we'll have a set of providers so that you can actually talk to your cloud provider of some sort. So those have names and parameters. For the cluster, there's going to be a series of different components that we can interact with. Those components might also have parameters. So if you think of the UCP configuration that's available, where you can define your metric scrape interval or your LDAP and SAML and all these different things, the different parameters that might need to be exposed there. And then of course resources. So we need to actually build something to run the cluster on. And again, we're organizing these by type, so you can have a set of instances, a set of load balancers. Oops, let me go back one. So that's the overall shape of what a cluster YAML file is going to look like. We're going to have a variable section, a provider, cluster, and resource. And now let's go break those down a little bit more. And we'll start with provider. So this is going to declare where the cluster is actually going to be built, whether in AWS, Azure, vSphere, and then some additional parameters that are at that sort of provider level, like region or location in Azure, or your server in vSphere. And we can also declare connections to different providers to build SSL certificates. So if you think of Let's Encrypt, we need to be able to provide just a little bit of parameterization there so that we can appropriately authenticate. So in Docker Enterprise 3.0, which is later this quarter, we will be shipping AWS, Azure, and VMware vSphere. Please come see us if you have another provider that is your favorite. Maybe another 3-letter acronym. So cluster, there's a bunch of different components that the cluster needs to think about. First and foremost, at the very sort of bottom layer is the engine. What sort of version of the Docker engine are you going to install? Is it 1809? Is it 1706? Is it going to be the new 1903? So the ability to configure that and provide additional flags that you might need to set for, say, engine logging. For UCP, there's a whole configuration block that can be provided. Not only can you provide the version, but you can also go through the full UCP config toml and include it in that block so that you can be able to check in your UCP state or declaration with everything else. DTR, same sort of story. You need to give it a version and then some additional options, maybe certificates for your endpoints.
Yeah, and so one of the final sections is the resource section. And in here, this is kind of where you're defining your state of resources. The resources can be worker nodes, they could be Kubernetes worker nodes, Swarm worker nodes, they could be separate database nodes you want to set up, things like that. That can even fall outside of what you would normally scope into a cluster for Docker Enterprise. And then so getting into kind of what some of the initial resources are, we have instances, which for most cloud providers are familiar with. AWS, you have T2s, XLs, everything like that. Azure, you have similar, as well as load balancers. And so within each environment and a different provider, these names may change slightly to be more provider specific. But then you can also set up things like DNS. And so if you're using something like AWS, we can hook directly into Route 53 and actually provision you host names that are tied to your cluster. And as Joe mentioned earlier, we can even go and tie into an SSL provider to be able to generate those certificates and apply them all during the cluster installation.
So let's look at an example, and we'll walk through this YAML. All right, so like we said before, we're going to declare some providers. We're going to deploy this to AWS. Goodbye. Nope, we're back. Region, US West 2. For Acme, which is a certificate generation service that works with Let's Encrypt, I just need to give them my email, and now you have it too. And that will provide the necessary credentials to basically lock down the number of requests I can make for certs, so I'm not like abusing the service. For the engine, like I said before, we need to give it a version. So we're going to have the enterprise engine from our stable channel and install 1809.5. For UCP, same sort of thing. We need to provide the Docker organization. We want the UCP version 3.16 to be installed. And then when we get to resources, we try to keep it as simple as possible to choose same defaults wherever possible. So we're leaving out a lot of detail here, but we'll show you another example where we fill it out to a greater degree. But the very minimum I need to know is how many managers do you want? Do you want 1, 3, 5? How many workers do you want? 50, 100? But with this declarative syntax, you can have arbitrary number of instance groups. So you can have a set of workers that are heavy on compute. You could have spot instances. You could have GPU instances, ARM instances, all defined within the same cluster definition.
Yeah, and then via labels, as you mentioned, you can actually label those nodes, and so this gives you more flexibility than what we had originally in DCI. Where in DCI, you really only had managers, DTRs, and workers. And so in here, you could say kube workers, and you can apply the Kubernetes orchestrator tag, label to that, and then when it spins up, it will automatically come up as a Kubernetes node. Or you can label different nodes as ARM, GPU support, and then using those labels in your stack declarations or in your Kubernetes YAML files, you can pin different pods to those specific types of workers.
We have a set of aliases built into it for OS, where we just try to find the best and latest image for like Ubuntu 18.04. We choose it from their owner, and we use a regex to find the latest version, so that we'll keep you with the latest AMI for that OS. Same thing with RHEL, same thing with CentOS, Windows. But if you want to bring your own AMI, you're more than welcome to do that. You can specify it by that sort of name and owner keep pair, or you can also specify it by direct AMI ID, and it would be in that same node grouping. So it would be managers, and then AMI, and then that information. All right, so now we want to actually talk to the machines and expose endpoints. So we've included AWS Route 53 zone creation. So you can create a subdomain in an existing domain, or you can use an existing domain if you don't want to, further spread out. Works pretty quick. Load balancers, then we're going to use that same domain to build a name for this load balancer. Since it's the UCP load balancer, we will call it ucp.crest.dci.docker.io. You can have an arbitrary group of instances to attach to that, and then a mapping of ports, which is the external listener : the internal port that it's going to direct to. You can use this for interlock, ingress, DTR. It's going to be the same shape, but just different, names and ports and instances. So what can we actually do with this thing? So we have the command line options here. Probably small for people that can see it, but we'll walk through each one in detail. So what you probably want to do on day 0 is actually create a cluster. So once you have that cluster definition ready to go, you can then use a very similar a set of commands that you would expect from the rest of our tooling, where you create a cluster using that declaration. You can give it a name, or we'll assign one to you if you want some, whiz-bang Wozniak or something of that nature. We'll give you one from the same set of names that all of our other services have. You'll also get an ID for that cluster, so you can refer to it in future commands by ID. And we also provide the ability to inspect the cluster so that you can get detailed information about the different things that have been provisioned. You can get, if you see, you had a production cluster or this DCSF and you forgot where it was, it'll tell you the region. Pretty much a reflection of all the parameters you've given the system. They all get resolved and then get emitted back to you through this inspection.
Yeah, so in the inspect is where if you haven't defined some of the values that we set defaults for, once you have created or done a dry run of your cluster, you can come in and do the inspect and see what our same defaults are, and then even kind of, if you want to from there, modify it further. And so it gives you kind of just the ability to see what your end results are going to be if you haven't gone through and filled in every single value for every different declaration.
So that's great. But I want to do more things with it. So how do I actually interact with the cluster once it's up and running? Whenever we create the cluster and it successfully finishes, we will create a context for you that you can then switch to amongst the rest of your contexts. So like the client bundle that UCP provides, which is a set of environment scripts and certificates, we'll provide the same mutual TLS with a context so that you can use your local CLI to deploy apps to your cluster. Now let's say we want to make changes. We have an update command that will take the desired state in the cluster declaration that you're passing to it, do a diff, and figure out what operations need to be applied to get to that desired state. So let's say you wanted to perform an upgrade. You could upgrade the version numbers, and that will detect that you have changed your UCP version or your DTR version, and we'll do a safe upgrade of those components.
Yeah. And other things you can do is such as if you were going to kind of manipulate the number of different different resources, you can do that. But I think we talk about that a little bit further down too.
Right. So scaling up. What he said.
Yeah.
Right. So if you wanted to go from 10 workers to 20, just change the number, and then you can be there. If you look at backup, we have best practices guides on success.docker.com, how to perform a cluster backup and cluster restore. This automates it for you so that you can perform a backup, supply a secret so that it can be encrypted, and that will generate a backup tarball that you can stash in your favorite S3 bucket or other backup storage location. So that you can then restore it. Yeah. So if something goes wrong, you have that backup that you can then use with the tool to restore that cluster to that previous state.
Yeah, and just kind of say the backup is a full cluster backup. So it's not just where normally you're going, you have to take a UCP backup, a DTR backup. This actually runs all of them and kind of consolidates them in, provides you a full cluster backup, not just the individual components. That you normally would have to go to backup Swarm, go backup UCP, go backup DTR. And then with the 3.0 platform, actually, we've introduced online backups for UCP. And so it used to be when you would go to backup UCP, you'd have to basically shut down all the containers on one of the manager nodes to take the backup. With Enterprise 3.0, you can actually now do that online, and those backups are visible in the UCP UI.
And all good things come to an end. When you're finally done with this cluster, we'll help you get rid of it so that you can do a Docker cluster RM of it by ID or by name. That will also delete the context so that if you had that context there, it'll go away. And if you delete the context while it's active, it will revert back to default. So let's get a quick demo before we go into use cases. Can begin.
I want to make it a little bigger.
Yeah. All right. So we want to take a look at the clusters that we have available. We can do an ls and see that I have 3 clusters: staging, development, and production. Looks like development failed. Well, those developers. We can take a look at our production environment, do an inspect on that. We see we have it on the dci.docker.io domain. Joe Abbey, if you have any problems, just email them. The provider, detailed information about the cluster, what versions I've installed. The resources that are available. See, I have it in high availability. But let's see what it looks like when you actually try to do a create.
Yeah, and kind of one thing that was also in there that's kind of provider specific for AWS is that you can attach tags to all of your instances and resources that are created. So it's good practice to tag everything that you're using so that you can then tear it down when you need to with a common tag value. And then those properties that are available there for each provider are provider specific. So what's there in AWS, the AWS provider might be different than what's there in the Azure and in the vSphere provider.
So at this moment, we're talking to AWS, figuring out what resources we need to provision. We got that list now, and the provisioning will start, where we'll start building resources. And then after that, it will go to the install. Yep. So we can take a look at what we're deploying in the background. You said code was pretty. So large. All right, like I mentioned, there's a variable section where you can define some parameters so that you don't have to keep rewriting the same cluster definition below. So in this case, I parameterized my email address. I made password a prompt type so that for my UCP password, the initial admin, definitely not Docker123. Password, it'll prompt me for that, so I don't have to worry about it being, in clear text here. It'll be stored securely in the background in the local state. Define the region as a parameter, and then the rest of the cluster can essentially be completely parameterized and easily shareable with others. In probably a week or two, I'll get this broken apart so that the variables can be one file and the cluster definition can be another. So you could have multiple different variable files to say have production, staging, and development. And then that one that one cluster definition will take those parameters. So kind of how like Docker app works in taking a compose file and having parameterization of it. If we look at a larger example, say our production, yoink. Same set of variables. In this case, we're giving it a domain and a subdomain to launch in. I'm using the nice server URL for Acme so that I'm generating non-secure certs, because I guess lots of people use that service from Moscone. For the password, which I guess that's why that one hasn't been working.
It was intentional.
Code reviews are great, man. When you can get like 100 people to review your code, you see issues right away. So then you can have your set of resources that we had previously defined. If we wanted to increase these or add different ones, we certainly could. All right, let's go back to our cooking show demo. So far, life is good. Yep, so we're running through the installation scripts, which will visit each node, determine by the role that they were defined in either their name or otherwise explicitly. It'll install Docker Enterprise, it'll install UCP, it'll install DTR, apply the labels that have been requested. Once this is done, it'll spit out the endpoint for you to visit. It'll create that context so you can actually deploy apps to it, and give you the ID so that if you wanted to, say, destroy it, update it, scale it, you could. All right.
Yeah, and this was the tool actually I use it extensively for internally at Docker for deploying clusters and managing them for a lot of demo purposes and whatnot. But I use this tool for deploying the Keynote cluster and also the cluster we're using it for all the demos in the booth.
We use it internally for testing. We have some Kubernetes end-to-end tests that run on an hourly basis or a nightly basis that run against a whole battery of tests, and we're using this system to basically create a bunch of different clusters that look similar but are running the different OS with different node counts.
Yeah, and kind of getting back to some of the use cases, like we said, the day one and day two operations is probably the primary use case for a lot of this, along with the best practices enforcement. And so all of our back-end automation is built based on all of the knowledge and power that we've learned throughout the years of deploying clusters. Some other kind of use cases that are pretty powerful for this are in being able to set up and stand up staging, QA environments, all of that, and something that you can set up and tear down if you wanted to as part of your CI. You could stand up a cluster on a build, deploy it onto that cluster, tear the cluster down when you're done. And from a support aspect of things, it's pretty powerful in the fact that if the customer or the person having the issue can provide you their cluster YAML, you can very easily reproduce their environment to do troubleshooting and further root cause analysis.
The resources are named in a relatively sane way, so you can take that cluster ID and directly look it up. You can also look up a cluster name tag that we provide for you. We even provide a date created so that you can get a sense of how old this cluster might be if you're doing a lot of different cluster deployments and need to reap them.
Yeah.
Yeah.
And those are the ones out of the box, and like you saw in his YAML as well, you can define custom tags if you want to for specific projects. There was one in there where it's project, the DCI, DCFS.
Yeah, so here under your region or under your AWS, you would do tags, and then we could have DC, SF, true. And then that would apply the tag to the cluster whenever you ran an update. Still going? All right, hey, we're done. So let's go check this thing out. To save time, I did not create a load balancer. I didn't create a certificate, so it won't look secure. Apologies. I did not get a sticker to the podium, though. May have been a bad call. Sweet.
Just got to remember your password now.
It's just nervous fingers. Cool.
You're gonna lock yourself out.
Yeah. Well, that was fun. Anyway, so when you make a mistake like that, you can say, you know what? Just go away. I don't want to see this anymore. Goodbye, hello world. Oh, that's right. I think I set my password to be hello world and not Docker. Who would use Docker as a password?
There you go.
Polycaps. Yay. It's just a white screen. There's nothing actually to... I really hope it does actually launch. That'd be great.
Yeah, that's the power of the Wi-Fi. Or did you actually get on the Ethernet?
Allegedly. There we go. Yay. Whew. Not today. All right. So that has successfully deployed. That was great. Goodbye. So then it'll take a look at the current running state, determine the resources it needs to remove, and about a minute from now, it'll be gone. All right. Any questions? Yes, sir.
Thanks. Looks great. We run Docker Enterprise where I work, and we make use of collections to segregate environments. I suppose those would just be node labels on different sets of workers, but I saw you had managers and registry and workers as groups. So how could you like make subgroups or like have different sets of workers in the same cluster? Is that an option today?
Sure. So collections we don't have today, but I think we would add it in cluster.
If you're doing day 2 operations, you could apply them. So if you were to spin up your cluster, go create currently how it stands, go create your collections, then manipulate your YAML to set those labels on those nodes, you can. The names that he's showing for the resources are just that, names. And so while they're called registry manager, that you could have you could change that to worker kube or whatever you wanted. And so you can define multiple groups of resources, and that's how you could then apply those labels to that specific the group only. So kind of an example I would use is basically having kube workers, you would set the orchestrator equals Kubernetes label in there, and then as it spun up, it would automatically apply those labels to it, and those nodes would be switched over to being extra Kubernetes workers instead of swarm workers.
So for instance, I just created 2 more groups, one for additional swarm capacity, another for GPU, and it'll just build those out. There's only a couple special names. If you call a group manager, managers, or UCP, it'll be like, I bet you want that to be a UCP manager. If you call it registry or DTR, same sort of thing. You can explicitly define what the role is that you want. Or say you want role Linux UCP.
Does that show up in the inspect output?
It does. It's in the generated section. I can show you.
Where are the ARM instances?
Yeah, I guess, sorry. Role is manager, and then role of DTR and role of worker. And if it's Windows, it behaves a little bit differently, but it's the same sort of application. It would be a role Windows. If the OS has Windows somewhere in or around it, so they make Ubuntu Windows, I guess that's going to mess up. But if it has Windows in the name of the OS, it will choose a Windows label for it. Again, you can be explicit and call the role Windows. And because Windows is different, we have to use different connections like WinRM to it. And it all happens behind the scenes. Keep.
Can we use it on existing clusters?
Can you use it on existing clusters? At present, no. We are working through the import logic so that you could. So that you can say, here's a bunch of tagged resources, or here's a list of IPs that I want to pull in, or here's an inventory that I've already produced, and import that in, and then it would be managed by this. But at present, or even talk to UCP and say, hey, UCP, give me the inventory. Got another one back there. But yes, the intent is to have the ability to import an existing cluster.
One more question.
Thanks. I have a question regarding this Docker cluster.
Yes.
Can we do like a step update on an existing cluster on some set of nodes only if we want to do the update? Can we do that? If we run Docker cluster update, it will just completely do the update, right? If
Yes.
we want to select particular nodes and
Oh, I
just do
see.
the update in that one.
So we have a Docker cluster managed cluster, and we want to do an update, but only on a subset of the nodes.
Correct.
Right. Yes. So with Enterprise 3.0, there's like blue-green updates that will provide that subset. So if you wanted to say upgrade just a certain set of workers to UCP 3.2.1 or 3.2.2, you have that ability. If you were just updating, say, the worker count from 5 to 10, only those 5 to 10 are going to be sort of visited and affected in that operation. But if you wanted to further isolate, I'd have to do something different.
Okay.
But that's a good idea.
But yeah, and the upgrade procedure does take into account, like, you're not going to upgrade all of your manager nodes at once and take your cluster down. So
Right.
It has sane logic to go through and do one manager at a time, making sure that it comes up fully before you're moving on, things like that.
Yeah, the current process is like that once we start, we can't hold it. It just goes, right, to complete the update. So sometimes we have a particular change window within time period we have to complete. It doesn't work. Can we pause and continue after that, or can we select certain nodes and just do during that time and then?
So the underlying blue-green update works by first updating the managers, and it does that in a serial fashion, updating one at a time. And then it's up to you on the workers how that is performed. If you want it to be all at once, or if you want to do just a subset of, say, 10 nodes, so then you would apply the green label to those. They get the latest version UCP.
Okay, thanks.
All right. Let's see if I...
Okay.
Oh,
I'll
another
take
one?
2 more questions. We got one right here.
Is this only in Docker Enterprise or also in Community Edition at some point?
At present, it is Docker Enterprise only. Yeah, it's gone. Any other questions? Okay.
Yeah, so about node upgrades.
Yes.
If you wanted to do an OS upgrade,
Yes.
I suppose you would just change the OS field. Would you then go and replace each of the nodes by a certain number of nodes at a time?
Right. It would be a create before destroy.
Okay.
So we would create additional nodes, join those to the swarm, and then once that completed, then the destroy will happen afterwards.
All right, and could you do that in a staggered fashion?
Right. In a batch mode, yes.
Okay. And so if we were to specify our own AMIs or use, like we use vSphere, so if we were to specify our own templates,
Yep.
that would be the same way?
Exactly.
Okay. Could I recommend to look into this collections thing combined with then being able to upgrade maybe multiple different sets of workers simultaneously, but making sure that you only take a certain number of workers from each group at a time?
I
That would
see.
be extremely useful.
Right. Right. So to further isolate that batch size that we're performing.
Yeah,
Gotcha. Yeah. Okay. I'll keep that in mind.
thanks.
That's smart. Yep. Oh, got another one?
Yeah, I didn't see your, where did you pull down the images for DTR and UCP?
Oh, I pulled them from Docker. So that was happening on the nodes themselves.
Yeah, so by default, I think we specify the version of UCP it's going to be pulling from the Docker repository. Theoretically, I guess if potentially looking at maybe the option of doing an air-gapped install, we may be able to put them into a DTR and pull from there.
Yeah.
I think that's something.
Yeah, so our
I know we
scripts
can-
have the ability to do offline installs. How this would function with that, you would need to specify the file location in that UCP section, and then that would pull that file from your local host or wherever it was specified and push it to the endpoint. We have a customer that's using that script today in their deployment. And they seem to like it.
After this question, maybe we could take just one last one.
I think he's back there.
I'm curious how licensing plays into this.
If you have licensed Docker Enterprise, it's included.
Okay, the whole cluster setup. So let's say I set up a second cluster in AWS, it would somehow reference my license, or it would just be.
Yeah.
Okay.
So credentials, that's something that's kind of happening behind the scenes and is pseudo sneaky, but doesn't have to be. So it knows well-known locations for credentials for other provisioning tools. So in this example, it was looking up the AWS credentials file that I have on my desktop. It was also looking up the Docker config, interacting with the OS credential helper to then grab my Docker Hub credentials, so it could then log in the machine to my store bits and retrieve my subscription on my behalf. So it's trying to say, okay, you've already logged into Docker. Like, stop giving me all the details. I'll handle this for you because you paid me money and you really should get that level of service. I mean, I love this subscription UUID. It's just, it rolls off the tongue, you know? So before we go back to the slides, we'll start the mega kill
We're a little
thread.
out of time here.
Oh, we out of time? Oh, well, blinking light, people want to go home. What is it? Clear environments. Yeah, ooh, so much destruction. So yes, I will be killing production, staging, and development today. All right, I think the last slide is thank you. Oh, what's next? Support for more resources, support for more resource types, some additional customization, some of the great ideas that we got from the teams here, or the people here, about how to do the upgrades and how they might want to do incremental slices. Well, of course, we want to hear from you. You've seen my email. You can also find me on any of the different GitHubs and whatnot. What else? Right, so we showed you declarative cluster management, integrates directly with your Docker Enterprise as a CLI plugin. It'll be available in Docker Enterprise 3.0. It will be in the beta as well, so that you can try it out and then have an easy way to try out Docker Enterprise without reading a whole new book of instructions. And we did questions. All right, well, thank you so much.